Hello, PlatformCon 2023. My name is Jeff Doolittle, and I'm very excited to be here to talk to you about technical empathy. In what is likely to be the least technical tech talk that you're going to hear this year at PlatformCon. Now, why is that? It's because I firmly believe that people matter more than technology. No amount of tools and technology are going to solve most of the problems that we face in our industry. Tools and technologies help, but ultimately what it comes down to is people, how we organize, how we work together, and I believe how we cultivate a culture of technical empathy in our industry. First, a little bit about me. My name is Jeff Doolittle, as I said, and my life's mission is that I help make good software professionals great. You can find out more about me and my writings and appearances about technical empathy and other topics related to software leadership by visiting my website, jeffdoolittle.com. I hope to see you there soon. So why technical empathy? Well, let me start by taking you down memory lane to a situation that I imagine many of you have experienced, as I have myself, where you're looking at some code and you're asking yourself, who wrote this horrible code? It's complex, it's hard to understand, it's not documented, it's just a mess. And then you discover this glorious thing called git blame for the first time. And so you type in git blame and you realize, lo and behold, oh, I wrote that code. Now, come on, you've had that experience before too. Unfortunately, I've had it more than once in my career in the early days. This reminds me of something I call the Homer Simpson principle. There's this episode of The Simpsons where Homer is holding a bottle of vodka and a jar of mayonnaise, and he's about to combine them and consume them. And Marge says, Homer, I don't think that's such a good idea. And Homer says, that's a problem for future Homer. Boy, I don't envy that guy. And this is why I say the Homer Simpson principle is also known as the don't hate your future self principle. You see, most of our challenges and opportunities are not technical. We've discovered the problem, and the problem is people, and the solution is people, and that's the problem. Maybe you've heard things like this before. We don't have time to design a clear, clean, useful API that properly reduces coupling. We have to ship it. Or maybe this one, who needs documentation? My code is self-documenting. Or the ever popular, it works on my machine. Or maybe you've heard this before, it must be user error. Side note, there are only two industries in the world that refer to their customers as users, the software industry and the drug trade. Another one of my favorites is saying that all APIs are HTTP APIs, as if there are no other protocols or transports that we can use to integrate different systems together. And I think another one that plagues our industry right now is swagger sufficient, it's all we need. We'll just render open APIs and we'll publish them everywhere and everything will be fine. And yet in many cases, what we're really doing here is we're just taking mayonnaise and vodka and shaking them up together and drinking them and saying, that's a problem for somebody else in the future, which just might be you. So what does don't hate your future self have to do with technical empathy? Well, in my experience, sometimes treating your future self as someone else is a good first step toward thinking about the needs of others. You see, interfaces are everywhere. Right now, there are interfaces between your ears and the speakers that you hear my voice coming out of. Maybe you love good cooking, and when you smell the food that's cooking in the kitchen, there's an interface. There's interfaces everywhere. In fact, there are interfaces from the largest structures in our universe all the way down to the quarks. But we often run into the some assembly required problem because sometimes our APIs leave much to be desired because they don't necessarily meet the needs and requirements of the person who's trying to adopt them. You've probably experienced APIs like this before. APIs that put an excessive burden on the integrator. Maybe they're poorly designed. Perhaps the requirements are unclear. Maybe the objectives were short-sighted. And ultimately, a failure to encapsulate volatility in these poor APIs leads to brittle, fragile systems that are frustrating and costly to maintain and extend. But you might be saying, we delivered amazing world-class components like what you see here on the screen right now. But you know what the customer wanted? Driving. I mean, how many layers of abstraction are we away at this level from driving when we ship these things to a customer? Fuel pump, piston, spark plug, radiator fan. Look, these might be fantastic components, but they are way too many layers removed from the needs of the customer. Maybe there is somebody who could take these parts together and get driving out of it, but it would require a deep and broad knowledge and experience. You'd have to know what parts are missing. You'd have to have instructions, or otherwise you're going to guess or assume. You end up with extreme coupling to implementation details. When you're driving, you don't want or need detailed knowledge about what is happening in the fuel pump. And ironically, driving a Tesla is very similar to driving any other automobile because these details are hidden from you as the driver. Now, a mechanic may need to know what's going on under the hood, but the driver on the day-to-day basis doesn't. This is very similar to a lot of software applications where a front-end team talks to a thin HTTP shim over a database. A vast number of software systems are built this way. And what ends up happening is complex orchestration logic lives in the worst possible place, the front end of your application. Imagine if all the complex timing logic of your engine was built into the steering wheel, the accelerator, and the dashboard. So what do good abstractions do instead? They put the hard work where it belongs, on the implementer, not the integrator. Delivering raw components like these puts the burden on the integrator, but technical empathy provides a shift in mindset and culture that cultivates greater clarity of responsibility, increases the empowerment of both implementer and integrator, and ultimately helps build and maintain trust between software delivery teams. So I want to cover 3 topics in the time that we have left. And these are insights and observations. I don't have time to be completely comprehensive, but I want to look at the hard skills of technical empathy, the soft skills of technical empathy, and what I believe it takes to create a culture of technical empathy. And I encourage you to come up with your own ideas about how you can increase the technical empathy of the teams that you work with. So let's start with the hard skills of technical empathy. When I think hard skills, I think of engineering rigor. This means containing complexity in the systems that we build, not just letting complexity run amok or letting it be somebody else's problem like future Homer. Another issue I see is this, that most software developers major in computer science, but that is not the same as software engineering. Computer science isn't bad, but just like I don't want a biologist performing brain surgery on me, or I don't want a chemist building an oil refinery, we need software engineers to be designing the complex cloud-native systems of the 21st century, and computer science programs often fall short. You see, you've probably heard the old adage, there's 2 hard problems left in computer science, cache and validation, naming things, and off by 1 problems. Well, I say there's 2 hard problems left in software engineering, information hiding and dependency management. Think about the cells in your body, for example. Think about how much information your cells encapsulate, how much information they hide, and how they manage their dependencies. And when things leak out of a cell or get into a cell that doesn't belong, well, that hits home pretty hard, considering what we've all been through the last 3 years, doesn't it? So what does it mean to engineer software? It means beginning to look at a world where there are APIs everywhere. It begins starting to read about things like systems thinking and systems engineering from authors like Donella Matthews. We also need to look to principles like consistency, cohesion, and loose coupling. We don't want our systems to just be cobbled together with baling wire and duct tape. The hallmarks of a good design are consistency, cohesion, and loose coupling. And these lead to the holy grails that we all want of component reuse and composable systems. Another hard skill that we need to cultivate is design reviews. Now, I don't mean code reviews here. Remember before I said there are 2 hard problems left in software engineering: information hiding and dependency management. We should be asking ourselves, do our APIs properly hide information? Do they help us manage dependencies in a clear, consistent way that prevents things from leaking out to the people that are adopting our systems? You ever realize that the more powerful an API is, the more information it hides, not reveals? What's leaking? What excessive coupling might there be in the design that we're proposing? Another hard skill is a focus on what I call the other ARR. If you've been in the software industry, especially in startups, you've probably become familiar with the 3-letter acronym ARR, which typically stands for annual recurring revenue. But from a software engineering standpoint, the other ARR is automation, repeatability, and reversibility. Do you have test suites for your systems? How automated are they? How about your deployment processes? Are they automated? Are they repeatable? Can you reverse things when things fail? Can you try again when things fail? These are engineering questions that we should be asking about the systems that we build. And finally, the often ignored Documentation. My uncle Jerry was literally a rocket scientist. He worked for Sandia National Labs and Lawrence Livermore Labs. And later in his career, he ended up working for a medical device company to try to help them improve their software engineering principles. And what was happening was every single device that was built was a one-off with specific customer requirements that were involved in building each device. The device was shipped to the customer with no specifications and no documentation. And anytime somebody needed to work on that device, the company would have to send a technician out and they'd have to crack it open and guess at what was going on. Isn't it great that we don't have any software like that? Haha. And what Uncle Jerry said is, Jeff, we just don't know what we're building. We don't know. We have to send somebody out every time to find out what it was that we built and figure out what to do to fix it. Do you think that was efficient? Do you think that was cost effective? I bet it was incredibly error prone. And yes, this does in fact happen every day in the software industry. So those are the hard skills of technical empathy. Let's talk a little bit about the soft skills. As I said before, the problem is people and the solution is people. And that's the problem. This is true of technical design work as well, because API design is a human design task that requires the soft skills of technical empathy. First off, I want to say that these soft skills are in fact hard. They're challenging to cultivate. But I have found that when software engineers cultivate these skills, it vastly improves their ability to deliver technical empathy and to help people to comprehend what it is that we're building and shipping in the first place. It starts with a product-oriented mindset. You see, for every interface, there is a customer. Those auto parts that I showed before, sure, there's a customer for each of those parts. It's just not the driver. We need to begin to ask with the systems that we deliver and we want people to integrate with, how do we make it easier for them to integrate with them? And how do we create a product-oriented mindset where we view them as the customer? And that requires a customer, or in this case, an integrator focus. How do we make our APIs easier for integrators to adopt? How do we hide information and reduce coupling? How do we allow them to adopt the systems that we're building without rigidly attaching them to the things they're integrating with? This requires cultivating interviewing and listening skills, being able to understand the needs and struggles of others, and then being able to come up with creative ways to address those needs and concerns. I think it ultimately boils down to learning to hug the cactus. Ouch. But what I mean when I say this is, we take on the hard things so that others don't have to. This is the height of technical empathy. And technical empathy works best as a team sport. So as we close our time together, I want to give you some ideas about what it takes to build a culture of technical empathy. The first thing we need to do is we need to begin to build trust. And we do that when we make and keep agreements. Without trust, all manner of dysfunctions tend to result, such as hand-wringing, buck passing, and micromanagement, just to name a few. Healthy teams and organizations learn to make and keep agreements to build trust, and effective leaders build trust by making and keeping their own agreements. Once we begin to build trust, we can begin to clarify roles and responsibilities. We can begin to answer critical questions about the what and the why. One of the first and most fundamental agreements to make is agreeing to clarify roles and responsibilities. When people find meaning and purpose in their work, they become focused and committed to delivering value, and they can't do that if they don't know what their roles and responsibilities are. But when they do, their personal goals can begin to align with those of their team and of the organization as a whole. This cannot happen without clarity, and effective leaders work to ensure role clarity. And finally, once we begin to build trust and clarify roles, we can begin a virtuous cycle of empowerment. Because once roles are clarified, team members can begin taking steps towards mutual empowerment. I know what you're trying to do, you know what I'm trying to do, and we can help each other out. This process accelerates the growth of trust, leads to greater levels of clarity, and then continues in a self-reinforcing cycle of health. And effective leaders help cultivate an environment of mutual empowerment. I look forward to seeing how we can accelerate our platform engineering efforts by learning to cultivate technical empathy. Thank you so much. Enjoy the rest of PlatformCon 2023.